7th grade. This is Tuesday, and we have a math lesson in front of us this morning. We have a short week this week, and I'm looking forward to vacation. I know you guys are too. Let's go to page 12, lesson 3, and let's get our math lesson done. And then you'll be you'll have one thing done this morning, closer to vacation. Let's work for that goal. And we have a couple days off. We don't have to think about schoolwork. So today though is Tuesday, and we have lesson 3 in front of us that we need to get accomplished. Looking at the lesson, you are to be writing numbers in scientific notation. And we've done scientific notation already. This is just one thing more that they're teaching you. To write a very large or very small rounded number in scientific notation, follow these steps. Move the decimal point until there is only one non-zero digit to the left of it. Drop the extra zeros and multiply by a power of 10 that shows how many places you move the decimal point. For large whole numbers, use a positive exponent. For decimals, use a negative exponent. All right, so what they're teaching us, and I'll do the example that they gave us was 14 billion. This is thousand, million, billion. All right, remember scientific notation, it is always a decimal point after the first number, okay? So it's always one number in front of the decimal point. So right now, our decimal point is way over here. They want you to put it here, and then I like to think of it as, what does it take to put it back where it was? Okay, it was originally here. We moved it to here. Now what does it take to go all the way back to there? And so we would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It would take a positive 10 to put it all the way back where it was at. So a person could look at this right here and would know exactly what number. They could multiply this out, 10 to the 10th power, and come up with this number. So basically, it's an easier way to write rather than having all these zeros. And remember, scientific notation is one number in front of the decimal point. Another example they gave us was 352,000. All right, so right now our decimal point is right there. We're going to write a 3.52 times 10. All right, we're going to move it to right here. Now what does it take to put it back where it was at? 1, 2, 3, 4, 5. 3.52 times 10 to the 5th power. Now let's do another example they gave us. Actually, let's go down to number 1A that we have. We have boy, it's so little, I about have to. All right, we have a decimal point. Seven, 8 zeros and 903. All right, so again, remember our scientific notation is always written one number in front of the decimal point. It's always a number and then point whatever. Times 10 Now, our decimal point is here. What does it take to put it back here? So remember when we moved it to the right, it's always positive. When you move it to the left, it's always negative. So if it's here, we would have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I have too many zeros. Yep, I added one too many zeros. So it's here, 1, 2, 3, 4, 5, 6, 7, 8. 9.03 times 10 to the negative 8th power. So we had to move it back to the left. So that's why we write it a negative 8. All right, let's look at 1b. We have 140 billion. All right, right now our decimal point is right there. We're going to write it as 1.4 times 10. What would it take to put it all the way back here? If it's here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 10 to the 11th power. 2a, let's look at 2a. We've got 5 zeros and 42. All right, we're going to write it 4.2 times 10. So we moved it here. What will it take to put it back where it was at? 1, 2, 3, 4, 5, 6 to the negative 6th power. Is it making sense, guys? If you have to move it to the right, it's positive. If you move it to the left, it's negative. And think in your head, what does it take to put it back to the original number? We always put it here, but what does it take to put it back like it was? We put it here. What does it take to put it back where it was? All right? You guys can finish the rest of those. Let me see what you have for today for your lesson. Looking to see if there's something that I need to remind you of. Remember on page 15, number 32, it's A with a little slash mark or an apostrophe. Remember that means the complement of A. In other words, set U is numbers from 40 to 60. Okay, then you're supposed to come up with what set A is. Then the complement of A is what numbers were not included in set A that are in set U. Does that make sense? I think that's all. I don't see a lot of confusing things. Up on page 14, number 18, use the proportion to figure those out. And 3.5 years, how many months would that be? Use 1 year equals 12 months, like put it over top, like this proportion. 1 year is 12 months. And then do a proportion over here. You've got 3.5 years is how many months? Okay? Do those in proportions. All right. Good luck on today's math. Hope it goes well for you, and I'll catch up to you tomorrow.